Generating interactive AI worlds with Genie 3. What if I told you the next great leap in AI has nothing to do with making better pictures, but with building entirely new universes you can actually walk into? For years, we've been spectators, but a monumental shift is happening that threatens to pull us right through the screen. Today, we explore the dawn of interactive AI worlds, where seeing finally becomes doing. The leap to interactivity. So, if an AI can learn to dream, what happens when that dream becomes a place we can visit? This brings us to the next evolutionary leap, a technology called Genie 3. We are about to witness the moment the simulation stops being a movie and becomes a destination. What is the single most important difference between Genie 3 and its predecessors like Genie 1 and 2? It's the profound difference between receiving a postcard from a country and being teleported there with a return ticket. The predecessors were postcard generators, beautiful but static glimpses of a place you could never truly visit. Genie 3 is the teleporter, a machine that builds the destination around you in real time. Can you give us a sense of the fidelity and performance we're talking about? The experience is shockingly fluid, like watching a live television broadcast from a world that was born seconds ago. The specifications of 720p resolution at 24 frames per second mean it's not a clunky slideshow, but a smooth, responsive journey. This level of performance is what creates the powerful illusion of presence and immersion. How does Genie 3 maintain a memory of the world it creates? It's like dipping a brush in wet paint. The model has a stunningly effective world memory. If you were to paint on a wall, walk across the generated world, and then return later, the paint would still be there, just as you left it. This temporal consistency is what makes the world feel grounded and real, not like a fleeting dream. Why is this consistency so difficult to achieve from a technical standpoint? It's like trying to build a skyscraper out of playing cards in a windstorm. Each new card or frame must be placed perfectly or the whole structure collapses. The model must constantly reference its entire history of actions to prevent accumulated errors from turning the world into a melting, drifting mess. Maintaining this consistency is a monumental balancing act. Crafting new realities. What happens when you give an AI the keys to the universe's creation engine? The result is a staggering diversity of worlds, a testament to its creative power. We're about to see how a single line of text can spawn entire realities, from the hyperrealistic to the utterly impossible. How well does Genie 3 understand and replicate the laws of our physical world? Its understanding of intuitive physics is like that of a child who has learned about gravity by watching things fall, not by reading a textbook. It can generate the terrifying spectacle of a hurricane or the gentle play of light on water with a believability that is deeply unsettling. The model just knows how the physical world is supposed to behave. Can it generate a believable natural ecosystem from a simple prompt? It appears to have the skills of a master botanist and zoologist, capable of generating a complete, living ecosystem from a simple prompt. You can ask for a lush forest and get not just trees, but flowing streams and wildlife that moves with a sense of purpose. It understands the recipe for a believable slice of the natural world. What about worlds that defy physics entirely? This is where the technology becomes a true surrealist painter, demonstrating an imaginative power unbound by our reality. It can conjure up fantastical worlds with floating islands or render an entire interactive scene in a consistent origami art style. It's a powerful tool for exploring worlds that defy physics and logic. Is it possible to visit real-world or historical locations with this technology? It can absolutely function as a form of time machine or teleporter. You can walk through a vibrant reconstruction of the Palace of Knossos in ancient Crete or take a boat ride through the canals of Venice. It's a way to experience historical locations not as static images, but as living, explorable places. How accurate are these historical or geographical recreations at this stage? These recreations are more like historical fiction than a perfect documentary. The geographical accuracy is not absolute. It captures the soul of a place, its general feeling and architecture, but you shouldn't use it as a map. Think of it as a beautiful, interactive dream of a place, not a factual recreation. The technology underneath. Any technology that can build a world from scratch sounds like magic, but it's actually a set of brilliant technical innovations. To understand how this is possible, we need to peek under the hood at the machine's blueprints. We're about to explore the technology underneath that makes these interactive realities possible. What is real-time autoregressive generation, and why is it a monumental challenge? It's like being in a play where an actor is improvising the script live, one word at a time, while ensuring it's consistent with the entire story so far. Real-time autoregressive generation builds the world frame by frame, a monumental challenge requiring immense computational power to maintain stability. One wrong word or one wrong pixel, and the entire illusion shatters. How does this differ from other 3D environment creation techniques like NeRFs? Techniques like NeRFs are like creating a stunningly detailed but frozen 3D photograph of a scene that you can walk through. Genie 3 is fundamentally different. It creates a living, dynamic movie that is being filmed and edited frame by frame as you move. This allows for a world with life and movement, which is impossible with a static 3D model. You mentioned consistency is an emergent capability. What does that mean? It's like a ghost in the machine, a skill that the model developed on its own without being explicitly taught. This emergent capability for consistency means the engineers didn't program a rule for object permanence. The model simply inferred this fundamental law of physics by observing it in countless hours of video data. How do users interact with the world beyond just moving around? You are not just a visitor in the world. You can be its director, using what are called promptable world events. You could be walking through a generated forest and, like casting a magic spell, type a herd of deer appears to have them dynamically integrated into the scene. This gives you an incredible level of dynamic world control. Why is this feature so critical for training more advanced AI agents? This feature is critical for training because it turns the simulation into the perfect sparring partner. An agent's true adaptability is only revealed when you can throw it curveballs, like prompting a flash flood in the middle of a navigation task. It's the only way to build agents that are resilient enough for the chaos of the real world. The competitive landscape. When a new apex predator appears in an ecosystem, it changes everything. That's what we're seeing in the AI landscape. To understand the significance of Genie 3, you have to see it not just as a new product, but as a new species of AI. Its arrival forces us to redraw the map of the entire competitive landscape. How does the press view Genie 3 compared to a model like OpenAI's Sora? The press has correctly identified that comparing Genie 3 to OpenAI's Sora is like comparing a film camera to a game engine. The consensus is that Genie 3 isn't a better movie maker. It's a fundamentally different tool. It's a neural game engine, a machine for building interactive worlds, not just for recording cinematic stories. What is the core mission of Sora, and where does it excel? Sora's core mission is to be the ultimate Hollywood cinematographer, a master of cinematic text-to-video generation. It excels at producing breathtakingly realistic, non-interactive video clips for things like short films or advertisements. If you want to direct a movie with AI, Sora is the camera you use. What about a more accessible tool like Pika Labs? What is its niche? Pika Labs has brilliantly carved out its niche as the quick, clever, and accessible tool for the masses. It's the perfect choice for generating short, punchy clips for social media or for the rapid prototyping of a creative idea. It's the brilliant indie filmmaker's camera, not the Hollywood studios. So if Sora and Pika are making better cameras, what is Genie 3 building? That's the perfect analogy, and it gets right to the heart of the matter. While Sora and Pika are focused on creating better cameras to film our world, Genie 3 is focused on building entire worlds from scratch. It's the difference between being a master cinematographer and being a minor god. Are there other key players we should be aware of in this space? The field is experiencing a Cambrian explosion of creativity. It's an incredibly competitive space. You have Google's own VO models challenging Sora on cinematic quality, and other powerful models like Kling pushing the boundaries of realism. The race for generative video is one of the most exciting and crowded fields in all of technology. Revolutionizing industries. This is more than just a technical marvel. The real-world implications are so profound they are hard to fully comprehend. We are about to discuss the transformative potential of this technology, which won't just change industries, but our very definition of reality. The shockwaves from this will be felt for decades. What is the primary motivation behind developing a technology like Genie 3? The primary motivation isn't just to create fascinating toys. It's to build the ultimate school for artificial intelligence. Its main purpose is to fuel research in embodied AI by providing a limitless, safe, and infinitely varied training ground. It's the perfect digital sandbox for agents like Google SEMA to learn about the world. How does this help solve the long-standing sim-to-real transfer problem in robotics? It directly confronts the Achilles heel of robotics, the sim-to-real transfer problem. By allowing a robot to train for 10,000 hours in a hyper-realistic simulation, it can experience a lifetime of failures safely. This makes it vastly more capable and resilient before it ever touches the unpredictable real world. How could this technology completely change the video game industry? It could completely shatter the traditional video game industry, which has been built on the painstaking, multi-year process of handcrafting static worlds. Imagine games with unique, procedurally generated worlds for every player, where the story is a truly adaptive, real-time narrative. The era of the static, scripted game world may be coming to an end. Could this also speed up the game development process itself? Absolutely. It's like handing an architect a sketchbook that instantly turns their drawings into buildings they can walk through. As a rapid prototyping tool, it allows developers to instantly test new ideas for game mechanics or worlds. This could massively accelerate the creative process and speed up development time. What is an unexpected application of this technology outside of AI research and gaming? One of the most profound, unexpected applications lies in the realm of mental health. Imagine a therapist creating a personalized, calming environment to help a patient safely confront trauma or anxiety. Beyond that, think of immersive surgical training, where a surgeon can practice a complex procedure 1,000 times in a hyper-realistic simulation before ever touching a patient. The road ahead. As we stand on the edge of this new frontier, the road ahead requires us to be both bold and wise. We must talk about the very real current limitations of this technology. But more importantly, we must begin a serious conversation about responsible development because we are deciding the rules for these new realities right now. What are some of the key limitations of Genie 3 in its current research preview state? In its current research preview state, the technology definitely has key limitations. The interaction duration is like a short battery life, lasting only a few minutes, and it still struggles with complex multi-agent simulations. Think of it as a stunningly powerful prototype, not a finished product. Why is the model only available to a limited group of testers right now? The controlled release to a limited group of testers is a deliberate and wise strategy of containment. When you discover a new, powerful element, you don't immediately hand it out to the world. You study its risks in a safe environment first. This approach is essential for gathering feedback and understanding the dangers responsibly. What are the most significant safety challenges this technology introduces? The most significant safety challenges arise from the potential to create convincing counterfeit realities. The ability to generate harmful or deceptive content that is interactive and immersive is a major concern. We must be incredibly careful that a tool for building new worlds isn't used to undermine our shared reality. How is the development team approaching these ethical considerations? The development team is wisely approaching these ethical considerations by building the brakes before they finish the engine. They are working in close collaboration with a dedicated responsible development team to build in technical safeguards from the very beginning. The goal is to mitigate potential harms before the technology is widely available. What is the ultimate goal of creating these powerful world models? The ultimate goal here transcends entertainment or even robotics. It connects directly to the holy grail of computer science. Creating these powerful world models is a foundational step in the grand quest to achieve artificial general intelligence. An AI that can truly understand and interact with a world is an AI that is becoming a true intelligence. How does an interactive world model serve as a critical stepping stone on the path to AGI? An interactive world model is a critical stepping stone because it provides the perfect digital playground for an AI to learn the most fundamental concept in the universe: cause and effect. A truly general intelligence cannot be built from static data. It must learn by doing, by exploring, and by understanding the consequences of its actions. This is the classroom where it learns to think. What is the one thing our audience should take away from this discussion about Genie 3? If there's one thing to take away from this, it is this: Genie 3 represents the moment AI stopped being a tool for just showing us things and started being a place we can go. This is the pivotal transition from passive AI to active, explorable AI experiences. We are shifting from being spectators of AI's creativity to becoming participants in the worlds it builds.